Today, I'm not trying to focus on any technical aspects of programming and syntax of these classes and objects being created in software. Rather, I'm trying to give you some practical examples of objects being used by the program, and so altogether show you timeline of interactions between them, giving you an example of what could be happening in real application. I'm switching back to the list of topics, and you can see that the part of the topics presented here are talking about MVC, or Model View Controller architecture. Let's say that we want to build an application that uses the heater and thermostat that we discussed earlier. So we can think about the user interface. So possibly we have a system here that has a main menu. Let me zoom in a little bit so you can see better my planning here. So we have a main menu in this application that says display current temperature, set thermostat temperature, switch scale between Celsius and Fahrenheit, and then exit the program. So these are the choices that we give to the user. So in addition to this, once they say display current temperature or make other choices, the application may switch to other screens, and you can see 3 more views that the user can see. Switch scale, use Fahrenheit or Celsius, or set thermostat temperature. And again, according to the scale that they choose, they may choose degrees in centigrade or Fahrenheit. We also have a possibility of displaying the current temperature. So these are all possible different views that we can have, that we can give to our user. So these bubbles primarily represent screens that the users will be presented. But at the same time, I'm assuming that there may be a useful object that controls this display in our system. Let's now add to this picture a set of business objects. We say that for instance, a thermostat and heater, and internally the thermostat has a set of member functions such as get current temperature, set heating temperature, change scale, because possibly the thermostat has a reading sensor, the temperature sensor, that possibly internally returns the current temperature reading in certain scale, possibly Celsius or Fahrenheit. So we have a function here to change the scale. And we also have a heater class, which has a very simple interface, a couple of operations which are turn on and turn off. So these are what we call business objects, and the model, the data model of our application, is made up of a set of business objects. And so these are the examples. So notice that I begin to kind of group this display is that this is my model, and the model is responsible for implementing business rules and other functionality specific to the problem domain that we're trying to solve. Normally we call this a business tier or data tier or model tier of our application. At the same time, a presentation tier includes all these possible views, right? So this is architectural decision that is often made to make the system maintainable and successful, to keep the business rules implemented by our business objects separate from any tasks specific to presenting the data to the user. You can see that we already have multiple views of all sorts of data and actions that we can allow our users to undertake, but at the same time, all control of the physical appliances, as well as keeping the scale internally and keeping the temperature readings and setting the heating temperature internally is done by the business object. In the third step, I would like to add another object to our system that's called a controller. The controller basically, as this comment here says, establishes a boundary between the presentation tier and the data tier. So we say that in a good software design, we always should follow the rule that any kind of data model specific objects, business rules, everything that solves the problem of mathematical formulas, equations, access to the database should all be done in objects dedicated to these tasks. At the same time, the view or presentation tier is never responsible for mathematical computations. It is only responsible for presenting the information to the user. It's like making it visible. And it also allows the user to take action. Like, for instance, they can choose specific menu item, click certain buttons, input the values. But directly, the presentation tier never makes changes in the actual data. How is it done? Is that the controller, which is placed here strategically on the boundary between the model and the view, is responsible for providing interface to both the model, the parts of the model and parts of the view to interact with each other. For example, in the controller, typically you will find operations or functions, member functions of this class, which allows us to, which basically correspond to every part of user interface present in these views. For example, display current temperature is a menu item, so therefore we need to take some action based on this user choice. And look, there is display main menu, also display current temperature, display thermostat properties, display scale, which would typically correspond to all of these choices. Right? So when we continue using these views, apparently the objects responsible for presenting information to the user and respond to user clicks, user actions inside this user interface will simply delegate the calls to the controller. So the controller then decides which of the business objects inside the model tier or our data tier should be used to take action according to the user choice, right? So once the data changes and is processed by the business tier, the controller is notified by the corresponding objects in our data tier, and the controller accordingly returns information back to the view, and the view will be able to display it. So the basic rule of model view controller architecture that I'm trying to show you here is that we have the controller class that separates the model and the set of views that we have in the system. And so they never mix. So there is never a situation where a possible object responsible for presenting the data on user screen actually goes and talks directly to the heater or the thermostat. The restriction is that only controller is allowed to decide which business object should be responding to a certain user action. So the view, the user interface layer here can only delegate tasks to the controller, and the controller in its own task delegates the task to a corresponding business object. So these are these rules. Basically, the summary of these rules is such that we try to separate the responsibilities here. Tomorrow, this user interface can change to a desktop or mobile app or web app So there could be different environments in which we can make these presentations. At the same time, the model, the problem domain that we're trying to solve, the set of business rules, all the mathematical equations can also be adjusted. And if these two tiers of the presentation and the business that we're trying to solve, if they're kept separate, then we have a lot of freedom to make correct decisions, to make updates in individual classes. So this is an example where objects each play a specific role, each have specific responsibilities, but at the same time, they take advantage of object-oriented environment to use certain set of rules to separate the work here, presentation and solving the problem at the business level.